Okay, again, lesson 75 is a rather important lesson for graphing. We're going to graph, we're going to write an equation of a line given a line on a coordinate system, and then we're going to learn the slope-intercept method of graphing. And I'm kind of bummed I have to teach this via video instead of in class, but maybe it'll work well because at least my lines will be straight. We're going to start out with two vertical lines, and we're going to write the equation of those vertical lines. I don't know if you remember this, but we can determine the slope of the line by how far it slants. Now if you look at these lines, these are perfectly up and down. That means the slope of vertical lines are undefined. So the slope of these two lines right here, the slope would be undefined if they're straight up and down. They're vertical lines. So if you have a vertical line, the slopes are undefined. Defined. Keep that in mind. If we're going to write an equation of a vertical line, you'll notice that if we found a point on these lines, if I found a point right here, this point would be 1, 2, 3. It would be -3, and your y coordinate would be 2. If we found this one, it would be, if we found another point, we could get -3, say 3, 4, 5. This would be -3, 5. You would notice quickly that every point on this line, the x-coordinate is -3. So the way you write an equation for a vertical line is you would say x equals -3. That's all there would be to writing an equation of a vertical line. One way I try to, if you have trouble remembering whether it's a vertical or horizontal line, is just to put your finger in the center of your x, and look what you get. You get a V going that way and a V going that way. There's a good V. And that makes an X, or it should make an X. We do another V. So if it's an x equals, it's always going to be a vertical line, and it's whatever x equals wherever it crosses on the x-axis. So let's look at the blue line. This one crosses at 1, 2, 3, 4, 5. So this one's just going to be x equals 5. And that's how you write an equation of a vertical line. Just keep in mind it's always x equals because it crosses through the x-axis. And every point has its x-coordinate as 5. And the slope is undefined. Let's look at some horizontal lines now. Horizontal lines, the slope is just flat. So for a horizontal line, the slope is equal to 0. It means it doesn't slope at all, so it's equal to 0. Think of the vertical line as if you were just walking along, you just bang on there. There's no slope. You can't walk up it without a slope. Undefined slope. So to find the equation of a horizontal line, you'll notice it cuts through the y-axis. So for these, it's just going to be y equals wherever it cuts through on the y-axis, which would be 2 for the green line. And for the purple line, it cuts through 1, 2, 3, 4. So it would just be y equals -4. The way you can also remember this is if you flip your y around, what letter do you get? You get an H for horizontal. This little thing is if you can't remember it. So just remember y equals is your horizontal line, it cuts through the y-axis, x equals is the vertical line. Next thing, we're going to talk about our y-intercept. A y-intercept is where the equation crosses through the y-axis. Keep in mind this is the y-axis, this is the x-axis. The y-intercept is the point where the line crosses through the y-axis. And you'll notice it's right here where this red line crosses through the y-axis. So the y-intercept, we say, would be 4. The y-intercept for the green line, where it crosses through, is at the point 0, -3. So we would say the y-intercept is -3. Now something that's really important is an equation written like this, y equals mx plus b. This is called the slope-intercept form of an equation. Brace yourself, this lesson is really long. There's just so much material in it. This is the slope-intercept form of a line. When we graph a line, we're always going to put it in this form because you don't have to draw a table if you can get it in this form. The b of this formula is your y-intercept. It's confusing because they call it b and not y. They can't use the y because they already used the y for the equation. So if an equation is in this form, y equals mx plus b, like you'll notice this one is y equals negative 1/2 x plus 4. It's in the form y equals mx plus b. The y-intercept is always the b. So by looking at this red equation, I can say, oh, my y-intercept is 4. I don't even have to graph it to know that. By looking at this blue equation, I can say, wow, it's in the form y equals mx plus b, even though it's minus. This means the y-intercept is negative 3. The other important part of this equation is this number in front of the x. And you'll notice that in our equation over here, m is the slope. So 1/2 is the slope of the line. So by looking at the equation in slope-intercept form, now you can see where we got the name. This is the slope and this is the intercept. We can just look at the equation and say, oh, the line's going to cross at negative 3 and the slope is going to be 1/2. Now you guys don't know anything about slope yet, so let's get into that. Slope is simply the rise of the line over the run of the line. So how far it rises versus how far it runs. Let's look at this previous one that I had up here. This red line, if we pick 2 points, say we pick another point over here, and we construct a triangle from that point to this point, and see how much it rises and runs, we would see that it rises 1, 2, 3. From this line it rises up 3. And it runs 1, 2, 3, 4, 5. Now if we go from point to point, we would actually go down 3, and then we would run 5. I guess that should be 6. I think I had the wrong number there. 6. So our slope would be going down 3 and going to the right 6, and that's why we have the slope of negative 1/2. If you're always looking at a graph from the left to the right, and you'll notice it goes downhill from left to right, so it would be a negative slope. Just like you always read from left to right, you do your line from left to right. Look at the blue line. From left to right, it's going uphill, so it's a positive slope. So let's see if I can find 2 points on this line. Let's construct a triangle here. That doesn't look like it crosses the line quite at the right spot. So 1, 2, 3. Here we go. We'll construct a triangle on this one. I'm not sure if that's exactly right, but we're going from point to point. We would go 1, 2, 3, 4, 5, 6 from point, and then up 1, 2, 3, and it's the same ratio. So our rise is 3, our run is 6, and that reduces to 1/2. So our slope is 1/2. This is a lot of information to take in, and I apologize. So do your best and we'll clear it up in class if you have trouble. So slope is rise over run from one point to the next, or how much y changes over how, this means change. It's a delta sign, it means change. Change in y over the change of x, and that's our slope. So let's look at these 2 lines down here and see if we can figure out what the slope is. So this first line, we pick 2 points on grid lines. The grid lines are where they cross right here. So I'm going to pick this point right here and this point right here. There might be other ones that you could use, like it looks like that one could be used, or this one. The book is going to be a little bit more clear than my drawing. So I'm just going to, from this point, I'm going to count my rise over run. I'm going to start at this point and try to get to this point. So I'm going to go down 1, 2. Let's construct our triangle first. Later you won't construct triangles, but you will in the beginning. So I went down 1, 2, and then I ran 1, 2, 3. So my slope for this purple line is m for slope -2 over 3. You can see it's going downhill from left to right, so it's a negative slope. Let's do the orange line now. Construct my triangle. I'm going to find 2 points. A little hard to tell on my graph, but it looks like here's one, and maybe here. So I'm going to construct a triangle like this. Maybe reaching a little bit with my drawing. But this one, going from point to point, I'm going to rise 2, and I'm going to run 1, 2, 3, 4. So my slope is going to be rise over run, and then you always reduce it. So my slope of that line is 1/2. The closer your fraction gets to 0, the flatter your line is going to be, because 0 would be just a flat line. Okay, next part of this lesson. We are going to actually graph a line using the slope-intercept method. This is really important, so don't tune out yet, or ever here. Okay, this equation is actually written in the form y equals mx plus b. Let's see if you remember it. M is your slope, and b is where it crosses the y-axis, or its y-intercept. This is called your slope-intercept method. So anytime you're told to graph a line, I mean, even before when we made the tables, remember we made these tables? You always solved it for y, so that shouldn't be anything new. This is just a lot easier. You can look at this equation and you can see where the y-intercept is. So what's the y-intercept? Think about it. Y-intercept, where does it cross the y-axis? Well, it crosses at 2. So you're going to find the y-intercept and the slope. B comes before m, so find your b before you find your m. Stick to alphabetic order. So the first thing you do is 1, find your y-intercept and plot it or graph it. So I found it. There it is, 2, and I'm going to plot it. Put my 2 in there. Yay. Okay, the second thing you're going to do is find your slope. So let's find it. There it is. I found it. The slope is -3 over 5. And if you remember from the previous problem, slope is rise over run. So you found your slope. The next thing you want to do is start at y-intercept and I don't want to say do your rise over run, but mark out your slope. This is important that you start at your y-intercept and not at 0, 0. So I'm going to start at my y-intercept, and my slope says go down 3, or rise -3, 1, 2, 1, 2, 3. So I went down 3, and then run 5 from that point. 1, 2, 3, 4, 5, and I'm going to put my second point. Once you have your 2 points, then you can construct your line going through those 2 points. Or as close as I can here. So that is your line, and that's the easy way to graph it. Whoops. So let's try another one. Just remember, we go down 3 because of our down 3, and then we go over 5. So our slope is negative. You can see in this graph Just by looking at the equation, you can see that it's going to be a negative slope. Let's try another one. This one is not in the form y equals mx plus b. So our first step is to get it into the right form by getting y by itself. So I'm going to get negative 2y. I'm going to subtract x from both sides. Negative x plus 4. Then I'm going to divide by negative 2. Y equals, I'm going to divide everything by negative 2. See how I'm doing that? So here, I'm not going to leave it in that form. I'm going to make it, these are going to be positive, right? I'm going to make it 1/2 x minus 2. Instead of putting x over 2, it's the same thing as 1/2 x. Now I have everything I need to graph it. So the first thing, remember we want to do our b, because b comes before m. We're going to do our y-intercept. I'm going to plot that. It's at minus 2, 1, 2. So our y-intercept equals negative 2. Next we find our slope. It's 1 over 2. So that's our rise over run. So think about it. Is the line going to go down this way, or is it going to go up this way? Well, our slope is positive, and we read left to right, so we're going to go uphill, so our slope's going to be positive. So we start at the y-intercept. Do not start at 0, 0. Start at your y-intercept. We're going to rise 1 and run 2 for our second point. So we went up 1 and we ran 2. So there you go. You have your 2 points. You just get your line out and you connect them as best as you can. You can use a ruler, of course, so you get some nice straight lines. So you got all kinds of problems going on there. A little bit of trouble connecting points with this. And that's our equation of a line, and you can even put little arrows on the end because lines go on and on and on forever. This is your y-axis, your x-axis. Let's try another one, then you can try one. Maybe I don't have one for you to try by yourself. Let's try this next one. Why don't you try this one and then come back and see if you got it. Okay, so I'm going to solve this one for y. Put it in the form y equals mx plus b. You have to drill that in your head. I'll write it every time. Y equals mx plus b. M is the slope, b is the y-intercept. So I'm going to subtract 5 from both sides. So we get 3y equals, I'm going to put my x next because I want it in this form, x minus 5. And we get y equals, I'm going to divide everything by 3. Just put that in there like that. 1/3 x minus 5/3. Okay, this time we have a little bit of a trouble because we have a fraction as our y-intercept. So don't let that scare you at all. And let me just make sure I copied that right. This is a really long lesson. This is the last one then. So your y-intercept is 5 1/3, which is the same thing as negative 1 2/3. So I'm just going to put that on there as close as I can. You can't be totally accurate on these. 1 2/3. And your slope, let me just write that, your y-intercept is negative 5/3 or negative 1 2/3. Your slope is 1 over 3. So from the y-intercept, you're going to rise 1 and run 3. So here we go. From this point I'm going to rise 1 and then I'm going to go over 1, 2, 3. And you can see it's a positive slope just by looking at it right here. Positive slope. So I have my y-intercept, negative 1 2/3. I went up 1, so that would be negative 2/3. And then I went over 3. And then I can just pull a line out and try to connect them. And you have your line. You can see there's trouble with this. And just put your arrows on the end. And that's how you graph using the slope-intercept method. Alright, that's it for lesson 75.